Very happy to have the chance to deliver on opening keynote talking about the development of China, of SMR in China. There is increasing interest in small modular reactors and their applications. Many SMRs are envisioned for niche electricity or energy market where large reactors will not be viable. SMRs could fulfill the need of replacing small coal power plants in North China. Small coal power plants produces 80 gigawatts electricity, most of which are aged and a major source of pollution. Phasing out of small coal power plant lower than 2 megawatt electricity is an important strategy of energy structure transition of China. SMRs could provide power for small-sized electricity grid. In the energy market of developing countries, small or medium-scale reactors are drawing more attention due to the limited power demand and requirement for net stability. Small plants can avoid the embarrassment of frequent low power operation of large reactor deployed in a small size electricity grid. SMRs could be used for regional heat supply. There are 140 cities of northern China are using centralized heating in winter. These cities cover almost half of the land area in China, and the population there is more than 700 million. In China, the industrial heat demand is around 1 billion tons of steam, equivalent to 120 gigawatt heat supply, taking 10% of total emission of greenhouse gases. In North China, heat is supplied for 4 to 6 months per year, with a power demand of around several hundreds of gigawatts, or 15% of total energy consumption. SMRs could be used as floating power plant, providing stable electricity for ocean resources development and island energy supply. SMRs could be used for seawater desalination. 90% of Chinese coastal cities are in lack of fresh water. Seawater desalination can be stable water source, which is free from seasonal climate change. The development of SMR in China. SMRs R&D have been carried out since 1980s in China. Most SMRs are of pressurized water reactor type and integral design. Heavy metal SMRs are still in very early stage. Integral SMR of PWR type is state of the art and its deployment has been started. Multifunctional application is of great interest. A comprehensive design for power production, heat supply, seawater desalination, etc., among a variety of design. CNNC focuses on 3 main models of such as ACP 100, DHR, and HTR-PM. The ACP 100 is based on 50 years experience on small reactors and 30 years experience on power reactors. The preliminary design was completed in 2015. The ACP 100 is based on existing PWR technology. A series of experiments were conducted on key components and systems. Mock-up of key equipment were tested. This is the specifications of ACP 100. The ACP 100 adopts a one reactor, one turbine design. The integral design eliminates the possibility of large break loss of coolant. The passive safety design makes it safer than Generation 4 standard, Generation 3 standard. The ACP 100 reactor design has passed the generic reactor safety review of the IAEN on April 22nd, 2016. CNNC announced the start of the Linglong, which is ACP 100, one demonstration project on July 18, 2019 in southern China, Hainan province. National Nuclear Safety Administration approved the preliminary safety analysis report on June 23rd, 2020. The first concrete of the demonstration power plant is expected to be poured in 2021. This is a picture from the SMR site on June 30th, 2020. The DHR is a pool-type district heating reactor with a thermal power of 400 megawatt, formally released in Beijing on November 28, 2017, which is having, just as I told you, we are talking a small reactor, should be less than 300 million megawatt, but this 400 megawatt is thermal. The DHR is developed on the basis of the light water swimming pool reactor. CIAE's 49-2 reactor served as a demonstration reactor of the DHR 400 program. This is a specification of DHR 400. DHR 400 is a multi-purpose application reactor for district heating, seawater desalination, and radioisotope production. It is capable of heating a construction area of up to about 20 million square meters, equivalent to 200,000 three-bedroom houses. According to these calculations, a single DHR 400 can supply heating for nearly 500,000 citizens, roughly the average population of a Chinese county. DHR operates in low temperature and normal pressure without the need of offsite emergency, and is featured with zero emission, zero coal methane, easy decommissioning, and low investment requirement. It is advantageous in economic efficiency, price of heat supply, far superior to gas-based heating, and comparable to heating by coal-based cogeneration of heat and power. CNNC initiated the demonstration program based on the 29-2 reactor in April 2017 and achieved effective heating supply for 3 office buildings on 20th November 2017. This is the first step of the CNNC's 3-step strategy of heating supply using pool-type low-temperature reactor. The second step is establishing a demonstration project. The third step is commercial application. CNNC officially submitted the project proposal to NEA on July 6, 2020. The demonstration project is planning to be built in Liaoyuan, Jilin province. HTR-PM is based on the success of HTR-10, inherit the characteristics of inherent safety and modular design. It's the world's first commercial demonstration of high temperature gas-cooled reactor, which is considered one of the Generation 4 reactor and has two modules with a total capacity of 210 megawatt electricity. HTR-PM has inherent safety features due to lower power density, good coated particle field performance, large negative temperature coefficient, large temperature margin, and other balanced system design. The decay heat can be passively removed from the core under any designed accident conditions by natural mechanism. This eliminates the possibility of core melt and large release of radioactivities into the environment. The first concrete of demonstration project was put on December 9th, 2012 in Rongcheng, Shandong province. Up to now, the cold function test of the two modules was completed. The hot function test is just started 30th December 2020, and it is expected to reach criticality in 2021 and to be put into commercial operation stage in 2022. Advanced SMR is playing an increasingly important role in the nuclear energy development of China. R&D of advanced SMR, such as water-cooled SMR, high-temperature gas-cooled SMR, molten salt SMR, has been carried out by many universities and research institutes in China. The key driving forces of SMR development are fulfilling the need for flexibility, flexible power generation for a wider range of users and applications, replacing aging fossil-fired units, enhancing safety performance, and offering better economic affordability. However, the development of SMR is still facing many challenges. More work should be taken in many aspects, including but not limited to establishing regulations, design standards, and supervision systems for SMR, obtaining public acceptance of SMR, implementation of passive safety, improving economic competitiveness. Thank you.
Thank you, Mr. Zengguang.